Thank you all for joining us. This is the Green Shoots webinar series from the Wilding project, which is considering rewilding, particularly climate smart rewilding around Europe. This webinar series is designed to give some very talented researchers a platform to showcase their research. And this week we're very, very lucky to be hearing from Gavin and Magali on the integrated framework for biodiversity, climate change and society. So without further fuss, I will open the floor to Gavin. Once the presentations are complete, we will have an opportunity to do a Mentimeter and ask you some questions, and then you will have the opportunity to put questions in the chat to Gavin and Magali. This is being recorded. Thank you. Gavin.
Good morning, everyone. Thank you for joining this seminar. So today, what I will present to you, maybe if you have the experience of joining previous Green Shoots webinar series, I will take you a little bit back to the very basics of what is climate smart rewilding, looking at the framework in its raw components, and how we can actually use this framework to pinpoint and target areas in Europe, at least in this case, for increasing rewilding, while we can benefit also through increasing the impacts of climate change and benefiting society in different aspects. So I will start with the background, and then I will go through the evolution of the framework and eventually showing you some hopefully cool maps. Now, biodiversity, as most of us know, is declining across the globe. Most of the reports that are coming through from different organizations are showing a clear pattern of biodiversity decline. Of course, there are most declines in more hotspots around the world, but in general, we have a general decline in a biodiversity loss crisis. Now, this is mostly driven by two main components. There are other components, but the main ones are habitat loss and climate change. Now, as a result, there were global efforts to try to mitigate those drivers of biodiversity loss, whether it is the so-called famous Paris Climate Agreement, the COP meetings, and the recently passed Nature Restoration Law. Now, one way to implement those policies is through what is called nature-based solutions. Now, nature-based solutions is basically taking different measures that will help to not only alleviate or mitigate the impacts of climate change, but also increase the benefits for local communities and increase the resilience of nature and people against climate change, sorry. Now, rewilding has emerged as a type of nature-based solution because of its positive impacts, both on society and on animals, species, and plants. Now, in general, rewilding is aiming to increase the naturalness of areas globally through different measures. So we have this kind of let's say, high impact cases of large-bodied species that are reintroduced to the landscape. So we have bisons, for example, that are reintroduced to different areas across Europe, and not only to increase the biodiversity of the area, but also to help decrease the impacts of climate change, because bisons, for example, were shown in this kind of really nice Yale study that the reintroduction of this species actually increased the carbon emissions, basically increased the carbon sequestration of those landscapes because of the different ecological processes that those species are doing through grazing, trampling, and other. So you have like this really cool way of showing how rewilding can help decrease the impacts of climate change, but also increase trophic complexity. Now, there were different frameworks that emerged in the last 20 years that try to explain how rewilding actually works in a more mechanistic way. But in general, the sense is to take this kind of degraded ecosystem, try to find the best measures that we need to implement, and eventually what will be the state after those measures are implemented. And we need to do this kind of long-term monitoring to see how the ecosystem is improving. But the main issues that we wanted to look at this kind of maybe hard-scale components that we can improve, and eventually we have higher biodiversity. So this is where the Perino framework emerged. This is the paper that published in Science in 2019 that was developed from our group in IDIV. And this triangle basically looks at three components, which is dispersal and connectivity, stochastic disturbances, and trophic complexity. Now, by enhancing those three components, we can actually increase biodiversity through the different rewilding measures, but also decrease the impact on human society and actually increasing benefits for society. But of course, we know that climate change will increase the uncertainty and uncertainties of ecosystems. So we are not sure that maybe increasing one component may harm or reduce the other components. So eventually, throughout the time, we may have maybe more wildfires, which may be good for the environment, but for us as a society, we don't want to have lots of wildfires, right? So we need to deal with these uncertainties of climate change by increasing all those components together and increasing the resilience of natural habitats. Now, I will give you a brief overview of what is this kind of rewilding measures. We have the two types of rewilding measures, which is the passive and active. So when we look at the passive measures, we basically look at what happens when there is a land that is abandoned, no more human pressure. Throughout time, you have more vegetation that increases. And of course, we have more carbon that is stored inside the ground. And eventually, this will, as I said before, it will increase the chances of more wildfires because we have more fuel load. And that's when we have to do maybe more active measures. So we need to maybe reintroduce large herbivores in this case to reduce the fuel load. And eventually, this will increase the vegetation complexity, but also maybe it will limit the carbon storage because it may release more carbon to the environment. So you have this kind of trade-off between those two measures. And eventually, in the end product for us for rewilding is to have this kind of very complicated and resilient habitat that may also help us to mitigate the impacts of climate change by increasing carbon sequestration, for example. And the way that rewilding works is these kind of three components, as I showed before, and those three components having different aspects. So if I increase trophic complexity, I have to look at the benefits and risks that can emerge for society. So if you have more wolves, you have more conflicts. But if you have more herbivores, you have more maybe vegetation complexity. And so you have to balance between those two components. But of course, we are looking at the aspects of climate change and human society together. So you have those the different components and what happens when we enhancing those measures. Now, when we think about where we need to implement those rewilding measures, usually we think about the protected areas. So we have the Natura 2000 network throughout Europe that can be a good ground for rewilding to emerge, to be implemented. But there is this kind of land abandonment phenomenon that already occurs throughout Europe and will increase by the end of this decade by more than 11%, according to the NUTS 3 models. So you have these kind of potential areas that rewilding can expand. And eventually we can, let's say, convert these areas that are maybe unproductive, maybe not really economic, to a more natural state that can help us, to increase biodiversity, but also to deal with the adverse effects of climate change. So as I said, climate change is increasing the uncertainties. So we are not going to may predict what happens to these ecosystems in the future. That's why we are dealing with this kind of notion of novel ecosystems that may emerge. because of rewilding, but this is something that we want to promote because in the end we want a resilient habitat. We're not looking at the past baseline. We're trying to promote more resilient ecosystems against climate change. And there are different measures that we can increase the naturalness of areas through different ecological restoration measures. But rewilding is really emerging as a more economically efficient way to increase the naturalness of areas by expanding whether vegetation complexity, but also increasing the overall resilience of these ecosystems to climate change. So the main objective, at least for my project, was to develop this new rewilding framework that not only advances climate-smart strategies, but also broaden the scope of rewilding by examining its relationship with climate change, biodiversity, and society. So this is the triangle that I've showed you before with the different components. And this is the new rewilding framework that we have developed here in IDIV, which is called the Climate Smart Rewilding Framework. And in this framework, we have the triangle from the Perino paper, but also we have expanded this framework to include climate change, but also the socio-economic aspects that may emerge from the different rewilding measures that we will take. So when we look at the numbers, we're at number one, basically that as a society, we want to promote these rewilding interventions to enhance biodiversity through the different components. But then what happens when we have more biodiversity? So what will be the impact on climate change in the case of mitigating climate change by increasing, for example, more vegetation, but also how biodiversity can enhance the adaptive capabilities of species to climate change. So we have more natural areas, so species may adapt better to climate change by either moving to other areas. So we have more connectivity that helps species to track climate change, but also looking at the benefits and risks that, as I said, can emerge when we have, for example, more carnivores or more wildfires. Okay, so we have to not only to say that everything is good and beneficial, but also risks that can emerge. And this is where the framework comes into fruition. So we can, look at the balance and the trade-off between benefits and risks for both society and for nature. Now, we developed this kind of climate smart action plan using different examples that enhance the different components. So what happens when we reintroduce species? We have more trophic complexity, removing boundaries like human obstacles, dams, fences, etc. So increasing connectivity and examples that help to, less suppressing wildfires, which sounds counterintuitive, but this is something that is actually good for the environment. So if we have these different examples, we want to look also what will be the consequences of those examples on climate change and society. So when we develop this table, we actually look at how we can increase trophic complexity. So as I said before, we have different examples. So we have species comeback and how it will help climate mitigation and adaptation, and also what will be the social benefits and risks. And we did the same thing for connectivity and dispersal, and for the stochastic disturbances. And once we developed the framework and this action plan table, the next natural step for us was to try to implement, or at least illustrate, how we can implement this framework. So we are now looking at the way we can do a special analysis, looking at those four components of mitigation, adaptation, benefits, and risks, and how it can help increase biodiversity, tackle climate change, and deals with the socioeconomic aspect. So at first, we look at mitigation. So for mitigation, we chose two variables, which is potential net primary productivity, basically meaning that what happens when we increase the biomass, the vegetation across areas, and where is the opportunity to do this, which is in this case the agricultural abandonment phenomenon that occurs across Europe. So you have these kind of huge landscapes that are abandoned. You have these areas that have potential to increase biomass. But we also looked at protected areas where these things can occur under protection. So it's not only areas that are basically not protected, but there are areas that have been abandoned. So combining those different components, we can look at this kind of rewilding potential. And this is how it looks. So we have climate mitigation potential using the different components. So when we look at the legend on the right, we have the increasing of according to the color scheme. So the darker colors indicates a higher potential for NPP. And the lighter colors meaning that there is very, very low potential. And the blue parts are the areas that are protected areas. So these areas are already either they're going to be rewilded passively or actively. They're still areas that will have increased biomass if we implement those measures. So on the abandoned landscapes in the darker gray areas, if you look at the overlap between those dark areas with purple and gray, you can find areas that are best to implement these kind of rewilding measures to increase carbon sequestration and eventually help us to mitigate the impacts of climate change. Now, the next step was to look at adaptation. So when we break this in the same way we did for mitigation, we're looking at almost the same variables except for the NPP. In this case, we are using climate velocity, which is basically the component that deals with how temperature changes across time and space. So how fast climate change will occur in certain areas across Europe towards the future. So this is like a futuristic point of view. And areas that have so-called high climate velocity will be areas that have higher climate change. So species will want to avoid these areas or move from these areas. And the notion here is to find areas that can expand corridors for species to move between areas that have high climate velocity to areas that have low climate velocity. So areas that are more climatically stable. So here, once we combine those variables together, we are basically creating a map that can illustrate the potential for creating corridors on abandoned landscapes. And the same color schemes applies here. So areas that are in darker gray and darker blue are areas that will have high climate velocity on abandoned landscapes. And we need to prioritize these areas for more corridors for species to move to more lighter colors, to areas that have lower climate velocity. And also, if there are protected areas, it will be easier for us to protect species as these corridors are developed. Sorry. Yes, thank you. Now, the final component was the benefits and risks component. Basically, we looked at benefits separately from risks. So for the benefits components, we looked at the willingness to travel to see a certain distance to see wildlife, which in plain words is basically the number of people that willing to travel a certain distance to see, I know, a bison or a large animal. And the opportunity here will be that the species that will expand their distribution, either naturally or through active measures, reintroducing species, as I said before with the bisons, we combining those two together, we can find areas that have high potential for ecotourism. So this is how it looks. Basically, areas with darker purple colors will be areas that have we will increase that we will have so-called species gain. So we will gain more species. In this case, it was large herbivores and carnivores, 8 species. And also the number of people that are willing to see those species will increase in those darker colors. So you can target those areas for, let's say, maybe develop more ecotouristic areas, biodiversity-related industries, etc. Of course, this is an illustrative example, but you can see the potential of using this framework to pinpoint for these areas for social benefits. And of course, as we have social benefits of expanding species, we also have the social risks. So in this case, we look at livestock density, in this case, goats, sheep, and cows throughout Europe. And what happens when we have more wolves and wolves and bears spreading across Europe, naturally or not. So combining those two together, we have this kind of risk map from rewilding. So the same color scheme applies here. So we have the darker purple colors are areas that we have, sorry, it's backwards somehow, and the numbers, it's supposed to be 0 on the lighter colors. But then you have like areas that are darker colors, areas that are more risky. And we may want to avoid, or at least try to balance the measures that we want to implement to decrease the risks of conflict that can arise with wolves or bears, either attacking or livestock, or just creating this kind of landscapes of fear. So we want to reduce these risks, but while also increasing the benefits. So this is why it's really critical to look at both components together when you do this kind of spatial analysis. And finally, this is all the maps together. So we have this kind of potential areas for climate mitigation, adaptation, and those trade-off between social benefits and risks. And another side note, this is a paper that is under review, and the next step will be to actually develop this kind of hybrid map of all those components together to give you like areas that are that will increase the benefits of all the components together. And these areas will be the best areas to rewild across Europe. So this is a work in progress, but this is a critical step towards this process. So in conclusion, I can definitely say that these climate smart framework and strategies can offer a promising approach for more proactive rewilding initiatives. Also, I think that we need to look at this climate smart rewilding framework from the climate policies point of view. So when we address these kind of measures as a really actual concrete solutions to reduce carbon emissions and land use change, it can actually contribute to the reverse of this biodiversity decline that across the world. And also promoting more resilient ecosystems in general, not only help wildlife, but it also ensure that we as a society have a more sustainable and biodiverse future for generations to come. So thank you very much. This is my part, and I will move my mic to my colleague. Thank you.
Yes, I'm gonna continue talking to you about the work we're doing here on rewilding. So I guess now you can see my slides. Yes.
Yeah.
So yeah, I want to talk to you about rewilding indicators, which are very much related to what Gavin has shown, in the sense that he presented you rewilding opportunities in those final maps. And this is a first step. I mean, this is related to the monitoring of rewilding, in the sense that it asks, where is rewilding happening? And as he showed, we can look at agricultural abandonment or at large mammals expansion to indicate that rewilding is happening. And so I want to show you a bit of the work that I've been doing on the possibility that there is for indicators. And as I said, it's essential to monitor rewilding, which is then very important to establish trends, but also for modeling exercises and also for policies. And so this question of where is rewilding happening here, as you can see, multiple places, multiple ecosystems, and we can look at them in terms of wildness, trying to see what is wilder. And I guess you would have also made this type of continuum with some, because like this parking has very low wildness, and the forest here on top that has a very high wildness. And so if we manage to qualify ecosystem in this sense, and if we can map it, if you imagine that these squares here are maps, we can see which area are wilder and which one are less. And then if we track this back in time, then we can see where in Europe are areas getting wilder. And so that is what I'm trying to do. But to get this color basically here, is it more red, is it more green? Then we need indicators. And to develop those indicators in a consistent way, this kind of asks what is rewilding, which is not at all what I'm going to answer, but is to explain that I'm relying on the work of Aurora Torres, who was working in our team previously. And the way she looked at ecosystem and at their rewilding level, so to say, is through two axes. The first axis, the x-axis, you can see is ecological integrity, and the y-axis here is human input and outputs forcing, which can be also, it's a synonym of human pressure. And here you have, again, 4 ecosystems from industrial agriculture to pristine areas, and depending on the human pressure on the system and on its ecological integrity, we can place it in this space. And so I've been trying to look for indicators of those 2 axes through, well, data mining, literature review, but also with workshop with all the members, I mean, a lot of involved scientists in WildD to see what could be considered. So as I said, well, rewilding is happening if ecological integrity is getting higher. And for this, I'm completely relying, of course, on the framework that Gavin presented, where we basically look at 3 components of this biodiversity that are increasing with rewilding. The first one being dispersal and connectivity, the second one, trophic complexity, and then stochastic disturbances. And here I'm giving some examples of indicators that can be used for those components. So for the first one, here you see a road, so we can look at continuous ecosystems. This is an indication of rewilding. For trophic complexity, we can, for example, look at large mammals because they're a crucial part of trophic networks and also because they've been depleted in the past. And for stochastic disturbances, here you can see this flooded area, and an example is to take as indicators the free-flowing rivers, meaning rivers in Europe that have no hindrance to their natural regime. Then if we look at, so this lower human inputs and outputs to rewild, here I've identified 8 components, and you have, I'm giving every time an example of indicators. So in agricultural system, an indicator of these human inputs could be pesticide use, could be higher, could be lower. In wood systems, then we can look again at wood extraction. How intensive is the forestry activity in those areas? Then for fire management, we can look at fire suppression that indicate this management. For hydrological system, that is the control that humans have over the system. We can, for example, look at levees. Are river channelized? How control is their flow. Here on the 5th element is mining. Here, for example, we can use as an indicator simply the mine extent. The next one here is the human action on wildlife. And here we think a lot, for example, about hunting, but we can also look at carrion removal, which is an action that is affecting wildlife. Then the 7th element is presence of humans, basically. And here we can, sorry, one second. Someone knocked on the door. I'm in a meeting. Sorry, guys. Yes, I was saying we can look at frequentation of people in, for example, in natural areas. And the last element here is artificialization, where we can use as an indicator built up areas. So you can see there is a large panel of indicators that can be used to look at ecological integrity and to look at human pressures. But the next step in my work was to, well, look for data. And first of all, most data we can see are coming from 3 sources. The first one is remote sensing, for example, for land use products or infrastructure maps. Then we can also have field measures that mean spatially explicit records, this, for example, for species survey or for fire suppression actions. And then also identify some census. There are actually a lot at regional, national, EU, at sector level, systems that, where stakeholders can report phenomenon going on, and it gives us data on what's going on, in the fields. So I've been looking quite extensively for data sets, and those data sets actually have some constraints in that we want to analyze those trends at the European scale with a resolution fine enough, and also we want to look at it back in time. And this actually is quite a strong constraint, and this led us to this question mark: what are actually indicators that we could use in our analysis? And on the next slide, I want to present some of the limitations that I found in my work looking for those indicators. So a first limitation is simply that there's no data. And on the right side, you have example, for example, carrion removal or local flood defense system. There's actually no European, even national databases indicating where is it happening, where are those. Then they can be data, but they could be limited. This is, for example, the case for dams. There are quite some databases indicating where are dams on river, limiting their flow. However, they mostly concerns large dams, while small dams can also have an effect on the dynamic of rivers, but it's also the case for deadwood removal or fire suppression efforts. A third limitation is the geographical extent, in that I'm looking for data all over Europe, and for some element it's not the case. And here I'm giving the example of a disturbance, which is avalanches and rock slides. And here we can have extensive data, but on some mountain ranges and not all over the continent. Fourth limitation is spatial resolution, in that we want to have a resolution that is fine enough, and it's not the case with all sources. And here I'm giving the example of the European Atlas of Mammals that has quite a large grid size. Then there is the historical perspective. By that I mean, how far back in time do data go? And actually, I was quite surprised that on some elements, it's quite difficult to find all data, so to say. And this is the case for roads and railways, where we have actually 15 or maybe 20 years of data, but not that old. And I'm saying this with what I know. If anybody in this presentation knows data or sources, of course, I'm more than happy to learn about them. So yeah, historical perspective was also a problem with alien species and with wildlife species distribution. And finally, there is the temporal resolution, in that because we want to establish trend, we want to have enough data to be able to qualify that trend. And for some sources, here I'm giving the example of irrigation of free-flowing rivers, we actually often have one point in time, which is not enough for us to establish a trend. So here you can see this work that has been done on looking at what indicators could be used, what data are available, what are limitations. And then I just want to give you a hint on 3 indicators that we are developing and that are, well, under development. So I will not be able to show you the whole trend, but basically we are looking at connectivity through the effective mesh size. We are looking at human use intensity, which is also an indication of control, human control on the system, and that gives us also information on, for example, how spontaneous are disturbances. And for this, we're looking at the human appropriation of net primary productivity. And finally, for trophic complexity, we're developing the trophic diversity index that was led by Nestor Fernandez, with whom we are working here. And so for connectivity, as I said, we're using the effective mesh size, which is the probability that any 2 points chosen randomly in an area are connected. That is, if I take 2 points in a landscape in Europe, what is the probability that they are in the same patch and that an animal present in one could reach the other point? And for this, we classify land use in those that allow movement. Here, I mean, it's schematically, but it's, for example, forests, grasslands, and bare grounds, and then land use that hinder movement. For example, urban areas, linear infrastructure, and intensive agriculture. And then we look at how connected landscape is. And so I'm going to show you one map. So it's 2018. Where you can see that the darker it is, the more connectivity there is. And we can see how in Northern Europe, but also like in Scotland, some areas in Southern Europe, especially along mountain ranges, there is much more connectivity than in other areas in Europe. And so as you saw on previous slides, we can have those data for since the beginning of the 1990s. Then the other indicator that I told you about is qualifying human use intensity is the human appropriation of net primary productivity, where here is basically the share of ecosystem biomass that is harvested by humans annually. And this is summarized here on this figure by Harbour from 2014, where this first bar is green, is the whole, is what is produced every year by an ecosystem in terms of biomass. And this is appropriated by humans in 2 ways. The first one is land use, and that, for example, you have a forest that is converted into a field and you will lose biomass. And then in this field, you may, or in this forest, you may harvest biomass and you will again, some of the biomass is going to be appropriated. And so what we're looking at is the share of the productivity of the ecosystem that is appropriated. And here is the higher it is, the higher the appropriation. And I'm also showing you only one map one time, and here for forestry, because I'm also looking at the impact of grazing, but I didn't want to go too long with the presentation, so we have time for questions and so on. So here you can see the appropriation in forests with areas like Northern Europe, Central Europe, the southwest of France and Portugal, where the appropriation is quite high. And finally, for trophic complexity, we're using an index, the Trophic Diversity Index, where it looks at the completeness of trophic networks focusing on large mammals. So first, we are indeed looking at large mammals. You can see all of the animals we're looking at here on this slide that have different, trophic behaviors with carnivores, bovids, omnivores, animals, and so on. And what we're looking at is first, we compare communities, that is the one we know are there currently or were there historically, and what they could be if there was no human impact. And then we compare what could be and what is through their traits. So we do a trait dissimilarity analysis to compare those. And so here, as you can see on the map, the higher the index, the more complete is the trophic network. And here again, we see some of the areas we seen earlier for connectivity with mountains of Northern Iberian Peninsula, the Alps, regions in Eastern Europe, and some region in Scandinavia. And then when we compile all of those, so those maps are coming from the report that was published in 2020, because I'm updating them, but I thought those ones are still prettier, so I wanted to show you those ones. And when we compile everything, and I entitled this slide as perspective because we are updating it right now and then bringing it back in time. You can see that the greener area is where those three indicators are indicate more wildness, and again we can spot the Northern Iberian Peninsula, Mediterranean islands, the Alps, Eastern Europe, and Northern Europe. So this shows you the work that is being done on the indicators, how we decided to focus on those three, and how I'm now currently developing those. And the future direction of WildE regarding the frameworks and indicators. So we want to look at the implementation of framework in case study, because they may have already presentations on the case study. So you can see here on the map the ones that are included in WildE. Then how the rewilding potential, what is the rewilding potential in Europe that can be looked at through modeling? And finally, we hope that this could be a guidance for policymakers and conservationists. And this is a common conclusion from Gavin and I, and this is also a huge thanks from both of us to all our co-workers in WildE. Thank you.
Thank you both very much. They were really, really interesting and informative presentations. We have got some questions coming in. Please, anyone else has any questions, just pop them in the chat. For now, though, we're going to ask you some questions using Mentimeter. If you haven't used it before, Mentimeter is very easy to use. You won't need to create an account or sign in. You just need to sign in from your laptop or your phone. I think we're about to, yeah. So if you either go to menti.com and put that code in, or use the QR code, we've got a few questions to ask you back, basically. Just give you all a couple of minutes to do that. Okay, so our first question is, which of the following do you think is a fundamental component of climate smart rewilding framework being proposed? when you pop your answer in, just press submit at the bottom of the page. We have a clear winner so far. Just give you a few minutes, see if anyone else wants to pop anything in. I think we'll move on to the next question now, please. And do any of you have any examples of how rewilding initiatives can enhance human well-being whilst minimizing potential negative impacts on livelihoods? Oh, we have an answer. That's actually quite similar to one of the case studies in the WildE project, which is interesting. Definitely. Get some great answers here.
Yeah, they're great.
Mm-hmm.
Mm.
Oh, that's quite a mix. But ecotourism seems to come out quite highly as a enhancing well-being. I think we will move on to the next question. Thank you. So if resources such as time and money are allocated towards data collection, which spatially explicit rewilding indicators should be prioritized? And you can choose as many responses to this as you like. So we're favoring wildlife species distribution at the moment.
Yeah, this is interesting.
Yeah, and actions affecting wildlife.
Surprising.
And flooding is seen as a priority over fire management. Interesting.
Yeah. The wildlife species still seems to be the most important one.
links back maybe to kind of the innate value of biodiversity. That's really interesting. Well, I think what we might do is wrap that up now. Thank you very much, everybody. And we do have a couple of questions. And I actually have a question too. So from Marguerite, how do you get the data on climate velocity? I think that was you, Gavin.
Yeah. So for climate velocity, we used data from World Clim, which is a large let's say organization, or I don't know, kind of data collections of different climate variables that create this kind of model projections. So we know what will be not only modeling the current climate, but also we have future projections according to different scenarios. So yeah, business as usual scenario, but like really optimistic scenarios, and how climate change will be, let's say, observed in these different scenarios. So for the climate velocity, you take in like one of those scenarios and you just project how temperature will change across time and space. So you're not only looking at how temperature will change like in 50 years, but also how the temperature will be affected across the landscape. So we take in the actual the gradient of the landscape itself to see if like mountains you have maybe like lower climate velocity because species they just have to move like a short distance to go from like this climate to the different climate, as opposed to like grasslands or more flat areas that they have to move across really long distances to reduce those impacts of climate change. So that's like this main sources. So usually from Worldclim or Chelsea. And yeah, this is like the way we calculate basically the climate velocity.
Thank you. And then a follow-on from that, again from Marguerite, how do you measure the willingness of people to see wildlife?
Maybe Magali wants to.
Yeah, so we are working here with a large team of scientists on rewilding and natural landscapes. And we have a colleague, Marek Gorzinski, working, he's an economist, and he has been studying willingness to travel. So it's basically through surveys to people, looking at what distance would they agree to travel depending on the type of ecosystem and the species that would be in it. And doing this over large population, you can deduce what is the distance that they would be ready to travel to see, for example, a wolf or a moose or those type of animals. And then we use those distances. And of course, the distance to travel is higher for herbivores than for carnivores, because for carnivores, there's also the dimension of fear. And so we take an average between different species to estimate what would be the willingness of people to travel.
Thank you. Frederic asked, how important is the climate mitigation potential for rewilding projects in your opinion? And are you including carbon sequestration potential actively in priority mapping? In fact, there's 3 questions. So let's start with how important is the climate change mitigation potential for rewilding projects in your opinion?
So at least in my opinion, I think that the potential way, as we're saying in Wildly, this like the climate smart rewilding approach is looking at how these measures of rewilding, whether it is passive and active, can enhance biomass or vegetation complexity. And by doing this, you can have a huge potential for mitigating climate change. So we can say, okay, let's do the active measures, which is like planting trees, but that's not, let's say, that's one solution. But this solution of rewilding is basically saying we sometimes just have to let nature go and to just leave the place. And this revegetation process can eventually will really increase carbon sequestration. So there is a huge potential for these kind of climate smart strategies. And I think that we will just see more and more projects popping up that are going to use this kind of rewilding, either passive or active measures. Yeah.
Thank you. Are you including carbon sequestration potential actively in priority mapping?
So
And maybe we can do the follow-up directly. How do you view the potential uncertainties of such data?
Okay.
We are not using it in our work and what we
Yeah.
presented. We are not using sequestration potential actively in that we could look at the different type of forests that can grow, and we can look for data qualifying, like estimating the carbon storage of those forests. And they are the type of landscape. Gavin can tell you more about peatlands, because you know about peatlands that store a lot of carbon. And regarding the uncertainty of such data, what do you think about the uncertainty of such data, Gavin?
Wow, that's a good question. So that's something that we're also struggling now with our paper, because we are not really looking at how we can what is like the carbon that is stored, like calculating how much carbon is actually stored. So what we are using is like a proxy to what actually will be like the carbon sequestration potential. But I guess that will be that these kind of uncertainties, yeah, it's something that we cannot say definitely that, you know, increasing those kind of like the NPP potential, for example, what we did, for sure can be something that will translate to more carbon sequestration. We can say that the potential for it will increase, but actually measuring more straightforward how this like specific landscape is sequestering carbon, it's something that we didn't do. We may do it now in this kind of revision that we're going through this paper. But yeah, the uncertainties are really, that are something that we are really thinking about. So we're not really sure how.
And there are uncertainties in how much carbon is stored by type of ecosystem, and in rewilding, because we don't have we have open-ended future for ecosystems.
Exactly.
There's also this uncertainty that is taken into account, where some changes in condition can have impacts on the carbon storage that would need to be taken into account. For example, in our colleagues who are doing modeling of this sequestration in the future.
Exactly. And also when we look at the way that, you know, when you try to have this area that is rewilded, and maybe at first, like the first couple of years, there will be more carbon emissions because maybe you have more wildfires, you have more events or ecological processes that will do the opposite. But the long-term effect, which is like what Magali mentioned, peatlands, that I really like to talk about when it comes to rewilding, you have like this pressure measure that you first lose a lot of carbon, but the long-term impact is that you increase immensely the amount of carbon that you can sequester in these type of habitats. So that's a really long-term way of thinking for at least for this for rewilding, for the climate mitigation aspects. But for other aspects, I think it can be even more straightforward and current, like corridors for climate mitigation, climate adaptation. So yeah, there are measures that can be more straightforward. Yeah.
Thank you. I don't even know how to word my question, Magali, but you were looking at urban as an indicator of kind of a block on the potential for climate rewilding. And this is kind of looking into the future. As cities should get greener and more permeable, does that block lessen? Or do you think we'll never quite achieve the point where cities won't be a block on rewilding, or on species and biodiversity?
I think you're right in pointing out that urban areas are diverse, and that a city center with concrete all over and will definitely be a barrier to movement, while peri-urban areas where you might have garden and things like this are much more permeable. And that in this analysis here, we are quite Manichaean in the sense that there is either passing or not passing. And I think that greener urban areas could be like crossed by wildlife, but that they will still not have the same potential as a natural area. And I think that would be my answer. That and also, I guess it also depends on the sensitivity of species. Or for example, it might be okay for, I mean, I'm not a wildlife biologist, I have to admit, but it might be okay for some very adaptable species, but for example, a lynx will never cross the peri-urban area to travel. Yeah.
Thank you very much. Well, thank you both for some really, really interesting work there. I've been looking forward to your paper coming out. Did you think it was about September we're looking at for that?
Hopefully.
Yeah.
Crossing fingers.
Fingers crossed for that.
Yeah.
But yeah, so everybody should be looking out for that. And thank you for giving us such insightful presentations and sharing your time with us this morning and your research. We have one last question very quickly. How do you communicate your results with relevant authorities who could actually implement the rewilding, especially regarding the modelled lands with potential for rewilding? And how do you include the importance of local context into this communication, coexistence, land use conflicts, etc.?
I think for now, the way it has been communicated, and there may be people in Waldi who know better, but there were some events on rewilding, for example, in Brussels, where senior scientists in our groups will talk about the Waldi project and explain what we already know about the benefits of rewilding and how to include local contexts. I think that through the framework, taking into account that there can be conflicts with, for example, livestock is a way. And then I guess that as time goes by and as the case studies in Waldi are developed, we will have example and data on actual cases. But I guess one element that we communicate is that the rewilding should be included at large scales, at the European scale, as it is in the nature restoration regulation. But it's always projects that are applied at the local level, and that should be done in accordance with the local context.
Thank you very much. So just to wrap up, once again, thank you for your time and your presentations. I put a link to a YouTube channel in the chat, which might seem odd, but in March, Wildy co-organised the When Nature Can Do the Job seminar with sibling projects, Wildcard and Rewrite, as well as Cinia and the Society for Ecological Restoration Europe. The event can now be watched as one quite long video, but it's certainly worth dipping in and out of and taking your time over. I just wanted to share that link with everybody. And with that, I would like to once again thank you both. Thank everybody for attending, and hopefully see you all at the next Green Shoots webinar. Thank you.
Yeah.
Bye-bye.
Thank you. Bye.